This is question number 25. It states a 55 kilogram ice skater is gliding along at 3.5 meters per second. 5 seconds later, her speed has dropped to 2.9 meters per second. What is the magnitude of the kinetic friction acting on her skates? So first, I just want to list the values that we are given. And the first one we are given is 55 kilograms for her mass. And then we are also given her initial velocity of 3.5 meters per second, as well as her final velocity of 2.9 meters per second. And lastly, we're given her change in time, which is 5 seconds. Now, given these values, we want to use an equation that has the final velocity and the initial velocity in it. So that will be final velocity equals initial velocity plus acceleration times the change in time. Oops. Okay, there. So we're going to be solving for acceleration in this first equation because, as we can tell, that is the only value within this equation that we were not given, and we will need it to later plug into the force equals mass times acceleration equation. So we're going to plug in our values. It's going to be the final velocity of 2.9 meters per second equals the initial velocity of 3.5 meters per second plus acceleration times, I almost rewrote that, times 5 seconds. So since we're solving for the acceleration, we obviously want to get it by itself. So we're going to subtract 3.5 meters per second on both sides. And that'll get us negative 0.6 meters per second equals acceleration times 5 seconds. And then since acceleration still isn't by itself, we want to divide it by 5 seconds. And that will give us negative 0.12 as our acceleration meters per second squared. And it makes sense that it's a negative because the question has stated that her speed was dropping, meaning she was slowing down, hence the negative. Now that we solved for our acceleration, we can go ahead and plug it in to our force equals mass times acceleration. And if we go back up here, we see that we were given a mass of 55 kilograms times by our acceleration we just calculated, which is negative 0.12 meters per second squared. And when we solve that out, we get negative 6.6 newtons. However, that is not our answer because they're asking for the magnitude of kinetic friction. So since they're asking for the magnitude, that means they're asking for the size of the force, not the direction. In that case, we will erase this negative, and our final answer will just be positive 6.6 newtons for our magnitude of kinetic friction. That's our answer, and here's the math that we did to get that answer.